So in problem set 11, we talked about multiplying expressions, and also we talked about the difference between terms and factors. Terms are numbers being added, factors are numbers being multiplied. Okay? Anyway, as the material starts to build up, it's really important to keep it straight. And so the things you can do, of course, doing lots of homework helps, and if you get behind, getting some help. And also reflecting on the homework, thinking about it after you've done it. Think of questions that you can ask in class. That's really important. Okay, let's start off with this one. Here's one from earlier problem set. Go ahead and get a piece of paper out and simplify this. Make sure you write all the steps down, okay? Alright, so if I were to simplify this, I'd work inside the parentheses, right? And you add the negative 12 and 9 and get negative 3. I'd write the whole problem down carefully. Inside the square parentheses, I'd probably use them with the multiplication now. 3 times negative 3 is negative 9. Then I would, inside the square parentheses, I'd probably add the negative 2 and the 9 and get negative 11. Almost done. See how it gets easier? Inside the curly parentheses, you see 5 plus 3 times negative 11. 3 times negative 11 gives you negative 33. And then what you do is, let's see here, you would then add the negative 5 and the 33, get negative 38, and don't forget the negative 2 outside. Final answer, I get 76. Okay, we're going to use the word factor as a verb now. When factor is used as a noun, it means numbers that are being multiplied. But when you factor a number, you're writing it as a product. Okay, so we use that word factor two different ways. To factor a number means to write it as a product. That's really important. Now in Math 60 and Math 80 and Math 90, you learn different ways to factor expressions. The verb to factor is really important in algebra. It's probably one of the most important skills that you're going to learn. There's lots of different ways to factor, and there's lots of different uses. In this class, we're going to use factoring in Chapter 2 to help us reduce fractions, but it's used a lot. So, again, the word factor is used two different ways. If it's a noun, we're talking about numbers that are being multiplied, and if you factor something, you're writing it as a product. Okay, so there's lots of ways to factor 24. Can you, if you want to write it as a product or a multiplication problem, this is factored. It's written as the product of two things. By the way, these two things are called factors, right? So when you factor 24, you're writing it as the product of two factors in this case, right? There's lots of ways to do it. Couldn't you write 24 as the product of the factors 8 times 3, or 2 times 12, or even, if you're lazy, 1 times 24, right? For negative 54, if you want to write this, if you want to factor this, it means write it as a product, there's lots of ways to do it. Negative 9 times 6, 18 times negative 3, negative 27 times 2, there's lots of ways. Negative 1 times 54. Usually, we're not really interested in just factoring it, we want to factor it completely. And often that means factoring into prime numbers, okay? Keep factoring as much as possible. Now, what is a prime number? A prime number is a number, it's a positive integer, first of all, whose only factors are itself and 1. So 1 is not a prime number because it has to have itself and 1 as factors. 2 is a prime number because the only factors of 2 would be 1 and 2. 3 is a prime number, the only factors of 3 are 1 and 3. 4 is not a prime number, is it? Because it has more than 2 factors. That's another way of saying it. A number is prime if it only has 2 factors. And it's a positive integer. So 2 is the only even number that's prime. If it's not prime, it's called composite. A composite number means it has more than just 2 factors. Alright, so if you want to factor into primes, let's look at this one. If you want to factor 42 into primes, what I like to do is I just like to say, okay, let's factor it and then just keep factoring as much as possible until you can't factor anymore. I factor 42, remember I factor means write as a product, as 6 times 7. Now can either of these two numbers be factored more? 6 can. 6 is 3 times 2, so that's how I like to do it. Some people like to use a factoring tree, which is fine. You could do it that way too. A factoring tree is a geometric way to kind of help you along. 42 is 6 times 7, and then 6 can be factored as 3 times 2. The only catch is when you use the factor tree, make sure you write the answer like this. In other words, see these ends? I like to think of these as the fruit at the end of the branches. Make sure you take the fruit of the end of the branches and put it over here. Okay? Let's do another one. If you want to factor negative 66, for example, factor into prime. So another way to say it would be factor completely. What you could do is you could write negative 66 as negative 1 times 66, first of all. That's a good way to go. There's reasons next chapter you'll see why it's nice to break that negative 1 factor off. And then 66 is 6 times 11. So are we done? No. 6 can be then written as 3 times 2. So the answer is negative 1 times 3 times 2 times 11. Now with the factor tree, if you want to do it this way, you could write it as negative 1 times 66, and then 66 is 11 times 6, and 6 is 3 times 2. But don't forget, the factors are actually the ends of the branches. So once you find those, use the factoring tree, make sure you put them all together over here. Okay, let's do a couple more, then I'll give you some to try. All right, let's say you wanted to factor, it said factor into primes, or it would say factor completely, negative 80. All right, well, I like to break off a negative 1 first. You can always do that. And like I said, there's reasons in chapter 2 where you might want to do that. So you can write it as negative 1 times 80. And then you can write 80 as, say, 8 times 10. And then 8 is 2 times 4, or 4 times 2. 10 is 2 times 5. Are we done? Can any of these be factored anymore? 4 can be factored into 2 times 2. So you end up with negative 1 times 2 times 2 times 2 times 2 times 5. However you get there, that's where you should end up. And you can write the factors in any order. Okay? If you want to use a factor tree, you can do that too. 102. Let's see, 102. A good question is, how do you know when to start? How do you know how to start factoring? Well, if it's an even number, you know that 2 goes into it. By the way, this is kind of a nice trick as well. If the sum of the digits is divisible by 3, see how you have 1 plus 0 plus 2? If the sum of the digits is divisible by 3, then 3 goes into it as well. That's a nice little trick. If it ends in a 0 or a 5, or a 5, then 5 goes into it, right? So you know how to do that one. So like I was saying, I know that 2 goes into it because it's an even number. I also know that 3 goes into this because the sum of the digits is divisible by 3. Anyway, I'm going to write as 2 times 51, and then 51, I know that 3 goes into that. 3 goes into 51 17 times. So I think we're done on that one. All right, negative 23. That's negative 1 times 23. I believe 23 is prime. So how do you know if 23 is prime? Well, you know that since it's an odd number, no even number goes into it, and then I would just start trying numbers. Try 3, try 5, try 7, try 11, and so on. So that's the answer. How about 105xy? So first, 105, we know that 5 goes into it. By the way, 3 goes into 105 too, remember? Because I said that if the sum of the digits is divisible by 3, then 3 goes into it. But anyway, let's write it as 5 times 21 times x times y. And then 21 we could write as 3 times 7. So this would be factored completely. 5 times 3 times 7 times x times y. All right, so go ahead, hit the pause button, try these, we'll go over them in just a minute. Okay, here we go. I don't use the factor tree, but if you want to, go right ahead. We all end up at the same place, right? All right, so 108, let's see. From what I said before, 2 goes into it. Does 3 go into it? Yeah, it turns out it does. It's 1 plus 0 plus 8 is 9, and 3 goes into 9, so that's a nice trick. So you could write it as 9 times something if you wanted, but I just wrote it as 2 times 54. And then 54 is 9 times 6. Are we done? No. 9 can be written as 3 times 3, and 6 is 3 times 2. So you have 2 factors of 2 and 3 factors of 3. That's the main idea. How about negative 84? Well, negative 84, I broke out a factor of negative 1. 84 is 42 times 2, I believe. 42 is 6 times 7. Are we done? No, 6 can still be factored. So you should, when all the dust settles, you should have negative 1 times 3 times 2 times 2 times 7. And if you wrote in a different order, that's okay. 72ab. I wrote 72 as 9 times 8 times a times b. 9 is 3 times 3. 8 is 2 times 4 times a times b. 4 is 2 times 2. So when all the dust settles, you should have 2 factors of 3, 3 factors of 2, a and a b. One point is don't drop the factors. It's easy to kind of like forget to keep them along, but make sure you do that. You don't drop any of the factors. Make sure you keep them along on each step. 59. Now, 59 turns out to be prime. Again, that is a interesting question. Is how do you know that it's prime? You would try all the basic numbers. Just start going up until you get to 59. It turns out you don't have to go that high because 59. If it has factors, then it's going to be something times something equals 59. So you really don't have to go up to 59. But if you go halfway up to 59, that would do it. But anyway, you know that 3 doesn't go into it because the sum of the digits is not divisible by 3. 5 doesn't, 7 doesn't. You just try things. There's no magic to it. Anyway, your teacher wouldn't give you 5,900,647 and ask you if that's prime. That's all. It is. In general, it's a very hard question. But these aren't that bad. Alrighty, we'll see you later. Bye-bye.